Hi, I'm Somayeh Hussaini. I'll introduce our ICRA 2023 paper, Ensembles of Compact, Region-Specific, and Regularized Spiking Neural Networks for Scalable Price Recognition. This is joint work with Michael Milford and Tobias Fischer within the QET Center for Robotics. Our work is inspired by the navigational capabilities of animals in unknown environments. Spiking neural networks that closely resemble biological neural networks have huge potential in robotics due to their high energy efficiency and low latency, especially when deployed on neuromorphic hardware such as Intel's Loihi 2. One potential area for developing spiking neural networks is the visual price recognition task. Given a query image, the visual price recognition task is to find the matching price that was previously visited. This is challenging as the appearance of the price can change drastically and geographically distant prices can look similar. VPR is used in many downstream tasks such as SLAM and localization. Here is an example of the performance of our model on the Oxford RobotCar dataset, which has a high appearance change. Instead of using continuous activation values like in deep neural networks, DNNs, we employ spiking neural networks, SNNs, which transmit information via binary spikes. Although DNNs are currently the state of the art in many tasks, the high power consumption makes them challenging to use in compact robotic systems. In contrast, SNNs are often much more energy efficient with lower latencies, making them an appealing option for robotics. We aim to develop a massively parallelized ensemble of spiking neural networks for the visual price recognition task that can scale prior work in smaller scale environments with only 100 prices to large data sets of more than 2,500 prices. We use an ensemble of spiking neural networks consisting of many expert modules. The experts are modeled via bio-inspired neuronal dynamics, leaky, integrate, and fire neurons, and an unsupervised learning mechanism, spike time dependent plasticity. Each expert learns prices in the local region of the reference data without being exposed to the whole reference data. We assign the neurons within each module to price labels based on the highest average responses to a price. Each expert has the same architecture and uses the same hyperparameters. So, at training time, the expert modules are independent and do not interact with each other, a key enabler of scalability. At deployment time, a query image is provided as input to all experts in parallel. Ideally, one could obtain the price matching decision using the maximum responses of all ensemble members. But we found that simply fusing the responses is problematic. As each ensemble member is only exposed to the local training subset, we introduced a global regularization before deployment to detect and remove the hyperactive neurons that are spuriously activated when stimulated with images from outside their training data. The neurons that are not hyperactive have significantly higher precision in responding to correct prices compared to these hyperactive neurons. Compared to previous work on spiking neural networks, our ensemble SNN has comparable performance in smaller scale environments. Importantly, it significantly outperforms the previous work on the Nordland and Oxford RobotCar datasets, where the previous work becomes computationally infeasible and fails catastrophically. Compared to conventional methods, our ensemble SNN in green performs similarly to conventional VPR methods, SAT, DenseVLAD, and NetVLAD. Here are some qualitative results of our method on the Nordland dataset. Given a query summer image, our model can find the corresponding matching spring image from a large reference set with more than 2,500 prices. For future work, we will pursue a few promising directions, including enabling high tolerance to viewpoint changes, use of event streams as input data, deployment on a neuromorphic hardware such as Intel's Loihi 2, and integration to a full SNN-based SLAM pipeline. Thank you for listening. Feel free to reach out and please try our code.